Good afternoon, everybody, and welcome to our webinar on custom geolocation for dashboards. My name is Eric Tobias. I'm the Vice President of Business Intelligence, and I'll be walking you through the process today. To keep in mind, what we're working on today is we want to enable you to do geographic mapping of data for elements that are not natively available in your dashboard platform. For example, street-level information such as addresses, property boundaries, perhaps some municipal information such as business districts, neighborhoods, emergency services, utilities such as energy and mineral resources, telecommunications coverage, etc. There's a wide variety of types of geographical data that you could use in this process. Today we'll be focusing mainly on secondary governmental administrative divisions. In this case, a forward sortation area, or FSA, which is actually the first three characters of a Canadian postal code. As an example, Unalytics postal code is M3C 1H9, in which case the M3C is the FSA, and the 1H9 is the local delivery unit, or LDU. Keep in mind that this logic and the process that we're describing are valid for Canada as well as the United States or any other country of the world. There are alternatives to what we're going to be going over. We chose this particular approach because all of the pieces involved are free. There are a number of other approaches that you could use that can incur costs ranging anywhere from several $1,000s to tens of thousands of dollars, either in services or in labor. Some of those alternatives include installing a web mapping service, a WMS server, purchasing map layers from a geoservices provider, purchasing pre-converted data sets specific to your dashboard platform. Just to give you an idea of what the basic process is that we're going to be going over, you do need to find a source file that contains the geographic elements you want. They need to be in some sort of map format, such as an ESRI shapefile or a KML file, which, for example, Google Earth uses. You then need to extract the elements that you need and convert them from whatever format they're in. Often it's going to be a polygon format into point format. You then take that data, you map that, and blend that with other data to generate choropleth maps, which is a fancy name for filled maps. To make this all work, you will need a few things. You'll need a boundary file. You will need a geographic information system, a GIS software package. You will need a dashboard product. You will need an advanced text editor, and we did specify advanced because the built-in Windows text editor, which is Notepad, will not work for what we're going to be going through today. In our particular case, this process requires the use of a conversion script as well. All of the resources that we're listing here, we can provide you a list of URLs to obtain all of this information and files. Just get in touch with us after the webinar at our info@unalytics.com, or we'll be in touch with you as well for those that attended and can provide that information as required. We are specifically using the following combination. We're using Quantum GIS 1.8, also known as QGIS. The dashboard application we're using is Tableau Desktop Professional version 8.0. The text editor that we'll be using is Notepad++. And the conversion script that we mentioned for this particular process is QGIS to polygon.vbs. Keep in mind the boundary file, as we mentioned before, is the Canadian FSA boundary file. Specifically, this is the one that we obtained from Statistics Canada, which is one of the government departments here in Canada. Some things to note ahead of time. Some geographic boundaries can require massive numbers of points to render them. For example, if we wanted to render all 1,600 of the FSAs in Canada, that requires almost 5.5 million vertices. Mainly, when you see the map shortly, you'll see there's a huge number of boundaries on oceans, which have lots of inlets. So the more accurate you want those boundaries to be, or the more jagged those boundaries are, the more points are required to draw them. So Canada is rather difficult to render, as opposed, for example, to the states of Wyoming and Colorado, which they're very straight lines. Would not be very difficult. The approach that we're using in this webinar does require that you have a workable number of points. So if you did want to try to use this approach for all 5.5 million vertices, that would be kind of problematic and would be unworkable. So try to keep a narrow focus on your data when you are using this approach. Otherwise, you likely will need to use one of the paid approaches. Keep in mind what we're going to be going through is we're trying to display product sales data within Tableau. We want to then take that data, map that along FSAs in the Toronto area, and then we want to enrich that sales data by blending it with demographic data, which has also been broken down by FSA. In the walkthrough, we're going to go over what's possible with out-of-the-box sales data. So that's not doing the geocoding or geolocation. What if we only use the geolocation data, or the geocoding? What is possible if we only use the demographic data? And then how do we get from what is available out of the box to what is our end goal? So we're going to start that process now. So let's go take a look. Let's go over here into Tableau. So let's go connect to our sales data first of all. Now that we've connected to that, let's see what's possible. So you'll notice first off that FSA, which is a geographic area within Canada, does not show up as being recognized geographically within the hierarchy that Tableau understands. So if we right-click on there, go to Geographic Role, FSA is not an option within there. So we can't use any of the built-in mapping functionality. We can do other things. So we could, for example, come in here and say list all of the FSAs, include the sales amount there. Let's make this a column chart. Move that around. So that's kind of useful. Let's put the big ones on the far left there. So we're going to say the ones with the most sales. Let's break that down by product. Color that by product, for example. So this is kind of useful. I mean, we can see that the most sales were in the K1S FSA. But unless you know all 145 of these FSAs, you don't necessarily know where that one is located. So just being able to see this information has limited usefulness. You know, there's a number of things that we can do in here. We can then create product breakdowns and do sales. Same sort of concept where we do columns or bars. But again, because we don't know what these FSAs are on a map, it's really hard to make use of this information. So let's take this one step further and see what could we do. Let's take this out-of-box sales information and see what's possible to render. So even if we went through a thorough dashboarding process instead of just the 30 seconds I just did, you might end up with something like this, where you have, again, the FSAs, you have the products up there, you have some search capabilities, which is great. Tableau does a lot of things for you that are really wonderful, but you'll notice that the closest Tableau has out of the box is the provincial level. So it says that our total sales were $50,134,000. But we do know that that all occurred down in this little area there, but we can't really render that information because Tableau doesn't understand FSAs. So again, while this is a great dashboard, it has limited usefulness. So what if we wanted to take now and we wanted to use some geographic information? Let's go take a look at our raw data. So we downloaded this file. Its extension is a .shp or shapefile. If we drag that into Quantum GIS back here, this will take just a second to load. While that's rendering, in most shapefiles you'll notice that there's 4 or 5 files that come with that. There's a database file, project file, shape file, some indexes. So all of those go along with that shape file. That will be fairly common whenever you're dealing with that. So let's look back here in the background. You'll see that it started to render that. It's still doing a few things. Let's minimize that. So now you'll see that this is the entire country of Canada. And you notice all of these island borders over there, which is what causes those 5.5 million vertices. So if we come over here now, let's say we're going to use a feature called Query, which allows us to zoom in a bit. We want to say, we want it where the place name equals, and let's get a list of those that are contained. We only want Ontario, so we'll double click that. So we're saying the place name equals Ontario. Let's hit OK. Let this think for a second, and then you'll notice that it filtered out all the rest of the country and zoomed in. But again, the place that we want is essentially that tiny little spot right down there where that hand is. So we could do some other things like zoom in on Ontario now, which is great, a little bit better, but it's still this little area down there. So what we actually need to do is we need to run another query. And I am going to take a shortcut here for just a second where I'm going to go grab this query right here. So you don't have to sit and watch me type 145 FSA codes. So I'm going to go grab that query, dump that in here, and then I hit OK. And now you notice again, there's that tiny little space down there. That is the Toronto area down there, the Greater Toronto Area, GTA. And there are, believe it or not, 145 FSAs down there. So again, we can zoom in, and now we're starting to see something that looks like a city. For anybody that is familiar with Toronto, you will notice that this pretty accurately aligns with the shape of Toronto in most maps. So we're getting to the point where we can start to use this. We're now going to tell Quantum GIS we want to select all of these. So we highlight all of those. They're now selected. We can do what's called open the attribute table. That gives us a list and selects all 145 of those. So you see them all listed here. And then we'll use a feature called copy selected rows to the clipboard. So we'll do that. And again, we're now using Notepad++. I'm going to open up a new worksheet. Paste that in here. And what you'll notice is we have all of these rows that contain shape information. Polygons, multi-polygons, has all of the coordinates, latitude and longitude, showing how to draw each one of those shapes. So what I'm going to do now is I'm going to save that. We're going to save that as GTA polygons. Since I just did this work already, I'm going to say replace that. You won't normally have that happen. That's done. So what we've essentially done, if we want to take a look at this, we just did, if we want to take a look at that in Tableau, that will not work because Tableau doesn't know how to draw the polygons and multi-polygons that are listed there. So we have to convert those. So we mentioned a script that's called QGIS to polygon. Let's run that. It's going to ask us what file we want to convert. So I'm going to come up here and I'm going to go to our source file, which is the polygons. And then you'll notice here in the background it has created some files and given them some suffixes on there, some attributes, polygons, header. What it's actually doing is it's reading that original file and doing a lot of work to that file and parsing that file to convert it. But what it's going to ask now is it's going to ask which column in your original file contains the unique identifier for each geography. So if we go back in here and we look in QGIS, that column is, here's all of the FSA codes, that is the CFSAUID column. So that's the column that we're going to need, which in this case is column 1. So let's change that to 1 and hit OK. And very quickly what you'll see that it says files complete, meaning that it has finished converting those for us. So if we go look at this now, if we look at the polygons in a converted state, now what it actually shows is it shows the polygons, it gives them a point order, latitude and longitude, and tells us what the FSA is. Now we're getting to something that Tableau can actually use. So let's go close this. I'm not going to save that. And now let's go see what we can do if we were to connect to that data. So let's drag the polygons in here. So again, this is just using nothing but the geolocated data. This is tab delimited. We're going to say OK. Connect live to that data. So what we're going to do is we're going to come in here and we're going to tell Tableau to draw all of the FSAs. What we also have to do is Tableau by default assumes that anything with a number in it is a measure, so we need to drag that up there until it's actually a dimension. We need to tell it you should be drawing a polygon, in which case the point tells it which order to draw the sides in. So that's the path over here. We need to actually tell it that. The point tells it how to do that. Polygon and subpolygon, I'm not going to go into any detail about what those are. It's a little bit complicated, but you do need to have those in Tableau. If you'd like more information about that, feel free to contact us. I can go into that in more detail. It's just we don't have time in a 30-minute webinar to be able to do that. Next thing we need to do is we need to add the longitude. And now once we add the latitude, you're going to notice that it actually will draw a map for us. So that's starting to look like this original map that we had back over here in QGIS. It doesn't have some of the boundaries. We can actually tell Tableau to draw those boundaries if we do a little bit of extra magic here using something called a dual axis. So what we do is we tell it on the secondary map, instead of drawing polygons, draw lines. And now you see it drew some lines. Blue on blue isn't going to work very well, so let's change that to white. Those are pretty thick lines, so let's make those a bit smaller. And now what we do is we come up here and we tell Tableau to draw those on top of each other, which is a dual axis. So now we actually see within there, we see those boundaries being drawn. So that looks an awful lot like that. Colors are different, size is a little bit different, but all of those FSAs are in there now. So this is getting to the point where it's pretty useful. At least it gives us geographic boundaries. We can do things such as searching. So for example, we could do a quick filter over here. If we wanted to find a particular FSA, we could do a search. So let's try to find Unalytics FSA. Whoops, 3C. Check that. So there is that. Shows you the general shape of it. If we wanted to see that where it exists in the map, we can actually come back out, zoom back out, pin this. So that tells Tableau, don't zoom in. All right. So you see that that's pinned now. So now if we come back in here, uncheck these all, and only check M3C. So that's roughly where M3C exists within the map. So that's fairly useful. But again, there's kind of limited usefulness. So even if we spent a while on this, we could come up with some pretty interesting dashboards. So in this case, we have one that actually takes it and gives it just the outline on a map, and one that gives it color coding. So again, we can add some labels, we can do wonderful things like that. We can still have our search capability, but this doesn't give us a lot of context with our sales data because we have not blended those sets of data together. So we've now given Tableau the capability to draw geographic boundaries, but we cannot add sales information to that just yet. But what we also wanted to do is we wanted to add some demographic data in here. So let's take a look at what that data looks like. We're going to connect to that data. In this case, it's the GTA demographics. Again, notice FSA. Even though that is a geographic boundary, Tableau doesn't recognize it because, again, we have not blended that. So we can bring that in here, and we can say, again, draw all the FSAs. We want that to be the columns. Let's say the number of households. We want to put that in there. So we drop that in our map. We put in a column. So this is kind of useful. Let's do a sort on here. Let's see, we can, I guess we're not, sorry, there we go, sort. We're going to do it descending on the number of households. So the FSA that has the highest number of households in it is M2N. So that's useful, but there's only so much that we can do with this information because we can't put it on a map. So let's assume that we spend a lot of effort and we produce a dashboard using what is capable just within Tableau. So in here we can see our population, ages 0 to 14, ages 15 to 24, 25 to 44. Here's all of the FSAs listed along the bottom. So this is good information. We can come over here, we can add to some search capabilities such as what is the average household spending versus some households have more people in them. So household spending broken down on a per person basis is average personal spending. Or we can even then say, what is that spending as a percentage of the total household income? So we're adding meaning to Tableau by being able to do this. So our personal spending, the demographics that we have include computers, cosmetics, spending on fragrances and grooming products. home entertainment, electronics, meals, so on and so forth. All of this information, which is good. Let's change this to meals. What's the average personal spending? Looks like number one is L4E. They spend the most on meals, which tends to be 3% of their total income. It'd be great to know where that L4E is located, but again, because all we're doing is connecting to the demographic data, we can't do that. So let's see what we can do if we try to blend this data all together now. So to do that, we actually have to connect to all of that data. So we're going to start by connecting to the polygons, which tell it how it can draw those boundaries. That should look fairly familiar. We're going to continue on, and we're going to say, now connect to demographic data. That's going to allow us to determine household income, household size. Let's add into that again our sales data. What we have to do now is we have to tell Tableau, because these are three different sets of data, how do they relate to each other? So we do that under the Data menu, under Edit Relationships. And we come in there and we have to tell it, when you're looking at the polygons data, which is our primary set of data, in order to blend this data, it has to match it on, remember that column name, CFSAUID? That is the FSA column. So we're telling Tableau, whenever you see one, that relates to the FSA column in the other. We have to do that with each secondary data source. In this case, we're going to come back in. We're going to say add CFSAUID to FSA. Let's just double check that, make sure those are both right, which they are. We hit OK. So now Tableau knows when we want to blend, it knows how to do that blending. So something that should look really familiar by now. Let's do the geographic boundaries. So all of them. Let's add our filtering capability. We're going to need to tell this to draw polygons again. And if you remember correctly, the point tells us the order to do them in. So that's the path. We also need to have the polygon and the subpolygon as detail items. We need to put the longitude on columns, the latitude on rows. And again, that should look fairly familiar down there. And what we did in the past is we said add some color based on, color each one of the FSAs differently. So we did that. Again, that's somewhat useful, I suppose, in that each FSA appears a different color. But let's now start to get fancy. And what we're doing is we're saying sales extract. You notice that there's a link symbol here. So that tells us that Tableau has recognized this blending relationship. Let's, instead of coloring it just on different FSAs, let's say color that based on sales. It looks like it's actually unlinked that, so let's link that again. And now we should actually see, here's our scale that shows light greens where there's low sales, dark greens where there's high sales. Looks like our FSAs here in the center of the city, we have the most sales. It doesn't actually show us what those FSAs are, so let's actually bring that in. So we bring that in and we put that on the tooltip. So now when we hover over there, we should see that there you see the CFSAUID, or FSA, is M5M, and that one is M4N. It seems to be, if I recall correctly, M4N had some of the highest number of households in it. So what if we could take this information and now start to gather additional information by adding demographic data in there? Well, we certainly can do those sorts of things. So let's call this sales. Start a new sheet. And again, it's going to start with the polygon data. So we have to do the usual. Draw all of our FSAs. Allow us to do filtering. Change this to polygons. Points on path. Include polygons and subpolygons as details. Put longitude on columns. Latitude on rows. There's that shape we've seen a bunch of times so far. Now we're going to link on demographic data. So here's our broken link. We're now, by clicking this, telling Tableau, blend this data together. So it clicks on that. Now we can use this information. So I think we had been using households. So how many households are in each of these FSAs? We're going to tell Tableau to color based on that. So what you'll actually see here is you actually see that some of these FSAs are out here a little bit. Let's draw FSA onto the tooltip. so we can see which ones are which. That's L5N and that's L5M. They have a high number of households. There's the M2N. Actually, I think I was thinking of M4N, but there's M2N seems to have quite a few as well. So now we can start to draw that. The other sales map was in green. Let's change this. Let's use blue on this one. So the darker the blue, the higher the number of households. Let's take another way of looking at this. So total population, perhaps. Color based on total population. And again, you'll notice that it seems like the dark colors are on the outside. So the FSAs are a lot larger out of the city center. So there tends to be more population with the larger ones. The household size. Again, that seems to be really low here in the center of the city, where a lot of the business district is. So you'll see that it tends to be fairly dark around there. But let's look at household income. Well, now you definitely see the household income. The center of the city is where a lot of the income tends to be high. There are a couple of exceptions out here, but in general it's kind of in the middle there. So this is our demographics data. Let's create our first dashboard where we combine sales. We're going to add now demographics data. It looks like we need to change this back to blue, so let me come back over here, edit our colors, change this to that blue color. Come back to the dashboard. So now again, our sales are in green up there, our demographics are in blue over there. We need to tell Tableau we're going to use this filter, we want to apply it to both of those elements. So the easiest way to do that is to say all using this data source. Now let's try that exercise again. Let's do a search. Let's see where our M4N. So again, Tableau has zoomed in for us automatically. Let's zoom back out. Pin this, because we actually want to see where that's located in the map. So we pin that map, and we pin that map. Let's do this again. M4N, and that's right there, kind of in the center of the map. We could do other things, like if we wanted all the M3 postal codes, we could click those. And you'll see as it starts to fill those in on the map. So we added another one down here. And we can do things now, for example, like we can start to see, let's add all the M3 FSAs. Now you can see those that have small number of sales versus those that have a smaller amount of household income. So ideally, we would like to see that wherever there's a dark blue, there's also a dark green. But it looks to me like we have some where that's not necessarily the case. Like this is M3B. It looks like it's a darker blue, but that is, while the sales are not bad, they're also not the darkest. So that starts to allow us to do some of this relating of sales and demographics to each other at the same time on the same map. So let's take a look. We could continue this exercise and build additional maps and build additional features, and it would be really great. But I've done a lot of that work already. So let's go take a look at what that would look like. I'm not going to save that. This is our combined dashboard. That should look familiar. There's the blue. That should look familiar. We've added this over here for, looks like we've split actually our demographics into population and spending. And then we have our sales. So the colors are slightly different. The layout is fairly similar. And the graphs are similar. We've changed some of the background from a grayish color to a darker color. But really a lot of it is kind of the same. And now also we've added the search capabilities we talked about earlier, where if we want to look at percentage of household income or average household spending versus average personal spending, we can do that. We also added an additional population setting that allows us to determine in population do we want to show total population, total number of households, or average household size. So we've added that search capability. This is the exact same thing it was before. We've added some data tables, and if you remember way back when we started this exercise, our product sales, so that's listed over here. But what we can now do, because we have all of these related to each other, is we can now start to compare and contrast. So where are our sales? Our sales look like they're fairly evenly distributed. We have kind of two codes over here, M4R and M5M, that look like they have some darker sales. Certainly one over L6T had more sales. Which over here is a light green, so the population isn't very high over there. So let's change that. Let's look at total population. So that's going to affect this one. So now you notice that the darker greens move to the outside, so away from the downtown core. Same, I think, if we do the household size. Again, it's away from the downtown core. But if we wanted to take a look at, now compare that, so even though our population or our household size isn't as large down there, let's take a look. Personal spending on grooming products, so that tends to be really high in the center of the city down there. What do people spend on meals? Also tends to be really heavy in the downtown core, but let's look at home entertainment. So that looks like some of the colors out here got a little bit darker. So people do spend a bit more out in the more suburban areas. Again, we can change that to how much of their income are they spending. Well, here now what you'll see that while the spending on home entertainment equipment may have been more distributed evenly, as a percentage of their income, it's much less in the downtown core. So if we were selling home electronics, we would really want to see that we should be seeing a lot more darkness down in this area. So perhaps we need to campaign more heavily in that particular area, or we need to figure out a strategy for how we address that. But now we can see sales related to total population that is available to us compared to how much they're spending. And we can do things, for example, like look here where we have the household income, and this happens to be sorted by highest household income, M8X. That is the one that has the highest household income. So let's see where that is. So we need to undo all. M8X. Click that. Let's see, average household spending. Well, so it looks like that's kind of to the southwest of the core area, or actually maybe it's just kind of west of the core area. So now we know where that is located. And we can see, for example, in M8X, the total population is 11,100 people. Average household size of 2.3 people per household. The average household income is $283,000. However, they spend on average $1,166 on home entertainment, which is $503 per person. So now we can see over here by using our filters that we sold a lot of products L and P to that particular FSA. But let's assume that product H was actually our home electronics product. It's not nearly as high as we would like it to be. So that gives us some ideas, some hints of where we might want to focus some of our efforts. Let's undo this. We'll go back to the entire view. So all of the filtering that we just showed, that was all done using a feature called Dashboard Actions within Tableau. There's also highlight actions, so we can highlight L5H, and you'll see that it shows you where L5H is located up there, and it highlights it down here for us. So if we scroll down here, there's L5H. and it filters over here. So it keeps everything in sync for us. So there's an amazing amount of work of investigation that you can do just with this one dashboard. And again, that's all done by linking the sales and the demographics data with those polygons that we drew by exporting and converting those from the original shapefile. So we've gone through our walkthrough. Just to give you an idea, in our investigations of shapefiles, which you've had to do many, many times, this is a list of all the different types of shapefiles that we've run across over our time. Street level addresses, property boundaries, bicycle paths, corporate regions, everything from business districts like neighborhood improvement associations, tax assessment areas, weather maps, parks, the list goes on and on. So pretty much anything that you can think of where you might want to have geographic boundaries, odds are you will be able to find that out there somewhere. We're going to look now and we're going to see if we have any questions that have come through. It looks like we have one question here. We've been asked if the list of resources that we used is available, and yes, we certainly will send that out. If you would like to get a list, for example, of where to get QGIS, where to get the conversion script, we can provide you Trials of Tableau Desktop. If you do not already have that, then we can get that to you. Just send us an email, and we can let you know that. Let's see if we have any questions from Twitter. No, it does not look like there are any sitting there. So with that, I will leave you our contact information. So info@unalytics.com. Feel free to send us a message there. There's our phone number, 416-441-9009, or you can go to our website as well at unalytics.com. And we will have the webinar linked from there if you want to go review this a little bit more at your leisure, where you can start and stop it. That will be available on our website. And with that, I would like to thank everybody for attending our webinar today and wish you a good afternoon. And thank you.